Okay, in this video then we're going to give you a chance to work with some of the formulas. We don't have any numbers for these two formulas, so you're going to want to be able to isolate just the letters, the variable by itself, without having any other help there to plug in. So let's take a look at the first one. Number 7, we're dealing with the area of a triangle. 1/2 base times height. And we have talked about and we're trying to isolate h. So if I were to come in here, put a box around the h, so I want to get rid of everything else. Probably the first thing that I'm going to do is to multiply both sides by 2 to get rid of that 1/2. Remember, instead of dividing by a half, it might be easier to multiply both sides by the reciprocal of 1/2, which is just 2. And so that's going to give us 2a is equal to bh. We're trying to solve for h, so the only thing that I need to do there is divide both sides. I'm trying to solve for h, so I should divide both sides by b, and when I do that, the b's cancel, and I end up with h is equal to 2a over b. And so that would be the way I isolate h on the first example, on problem number 7. The surface area of a cone. The surface area of a cone, and I certainly did not remember that on my own, but they give it to you here, is S. The surface area is equal to pi r squared plus pi r times L. And I believe here L is going to be the lateral height of the cone. The lateral height of the cone means the length from the sides of the cone, from the base up to the tip of the cone. So if I were to draw a quick example of that, if a cone looks something like this, then the altitude of the cone would go from the center of the base up. But the lateral height would be this height here, would be the length of a line drawn from the vertex, from the tip of the cone, a straight line drawn down to the bottom of the cone. Alright, so that's what's called the lateral height. Now we want to isolate that, and here it's not too bad. We have only one L. So we're simply going to begin by getting rid of the addition and subtraction. And we'd have S minus pi r squared is equal to pi r L. At this point, all we want to do, divide both sides by pi r, and we end up with L is equal to S minus pi r squared minus pi r. And that's really it. That's all we have to do to isolate the L in that equation. Alright, so hopefully you're getting some more practice with how we do this. Alright, in example 5, we want to rewrite the formula for temperature. We're given in the packet there that the temperature for Celsius is 5/9 times the temperature of the Fahrenheit temperature minus 32. We usually, at least in America, we talk about temperature in terms of Fahrenheit. So we would most readily know that. For example, today might be 65 degrees. And we would plug that in for F and then subtract 32, multiply that by 5/9, and we would get what the centigrade temperature would be. But what we want to do here is, without plugging anything in, we want to solve for Fahrenheit. So we're going to start out over here. C is equal to 5/9, capital F for Fahrenheit, minus 32. When we have a fraction multiplied, the very first thing we want to do is to get rid of that, and we multiply both sides by its reciprocal. So in this case it would be 9/5. So we would have 9 over 5c is equal to F minus 32. And we're one step away from isolating. We would add 32 to both sides, and we would end up with Fahrenheit is equal to 9/5 of the centigrade plus 32. So somebody who lived in another country where they know the centigrade temperature readily as we know the Fahrenheit, and would want to know what the Fahrenheit temperature in America, in New Jersey, was at some particular time, they would take their centigrade temperature, multiply it by 9/5, add 32 to it. So then let's go on and take a look at this example number 6. Here we're given that Mercury's temperature is 427 degrees Celsius and that Venus's temperature is 864 Fahrenheit. And we want to know which one has the greater surface temperature, Mercury or Venus. And I'm probably going to go out on a limb here and say that the one closer to the sun should be hotter. And so that's probably going to be Mercury. But what we would do in this case is pick a temperature, either centigrade or Fahrenheit, and convert the other one to what we want. So since we, at least here in America, we think of temperature in terms of Fahrenheit more readily, I'm going to convert the Mercury temperature to Fahrenheit and compare that to the 864 degrees on the surface of Venus. So let's see what we get. So here's an example of how we would use this. Well, we know that Fahrenheit is equal to 9/5 times the Celsius temperature. And so we would put a 427 in here, and then we're going to add 32 to it. So if I were to take 9/5 of 427, what I might do first is divide 427 by 5 and multiply that by 9. I'll bring up my calculator. Alright, so 427, I could multiply that by 9 first. I'll get smaller numbers this way. 427 divided by 5 is equal to 85.4. Now we want to multiply that by 9, and we get 768.6 plus 32, and we end up with 800. Interesting. 800.6. And so we would have 800.6 degrees. So remember, this is the Fahrenheit temperature for Mercury. So it seems to indicate that the temperature on Mercury is lower than the surface temperature on Venus, even though Mercury, if I'm not mistaken, is closer to the sun than is Venus. So unless you can show me where I made a mistake, I'm going to stick with that. And we will go on to do some more examples in the next video.